We are being recorded. All right, so we're being recorded. I'm going to give you a moment to copy down this example. Okay, take a moment to copy down the example.
Just going to grab some tape out of here so I can fix the shower thing upstairs. There you go. Double-sided's good. No, this is fine. This is perfect.
Okay.
Just got to fix this little plastic as you go on the shower. You know,
Okay. So we want to evaluate this integral. We want to find the antiderivative of 3x times the square root of 1 plus x squared. Now, offhand, does that resemble any of the common antiderivatives formulas you've seen? Does it resemble like the opposite of the power rule, or the opposite, the antiderivative of the sine or cosine? How many of you is this something new? Something new for you? It should be new, right? That's right. Indeed, it is. Thank you. Thank you. Well, what makes this antiderivative hard? I mean, what's kind of making this antiderivative hard to find? What's sort of the complicated part of the problem? Is that the
square root?
That's right, Michael. The square root. The square root being in there. Or maybe that was Snake. I didn't, sorry. but yeah, the square root. So what we have to do is we have to transform this integral into an integral that's easier to do. Okay, I mean, we have knowledge of certain antiderivatives. We know the formulas, we know the rules. You learn them in Calculus 1. You know the rules for certain antiderivatives. We have to do a substitution to make this integral easier to work with. So since the square root is the hard part, why don't we substitute and say u will equal 1 plus x squared? Okay. So let me show you what I mean. Let's get to the solution here. To make the substitution, I always think about what's kind of the hardest part of the problem. And that 1 plus x squared under the square root is difficult. You know, if it were something like this, if it were, the integral of 3x times the square root of x dx, that would be easy, right? Because square root of x, I could write that as x to the 1/2 power. Okay. And then I'd have the integral of 3 times x. Well, this is x to the first, so it would be 3 times x to the 3/2 power, because you add the exponents. That's a 3 dx. And this integral here, I can do it, no problem. But we don't have an x under the square root. We have a 1 plus x squared. So we're going to let u equal 1 plus x squared. So let's go ahead and do that. Now, when we let u equal 1 plus x squared, we're making a change of variable. We're doing a substitution. We're going to convert this integral to an integral that was with respect to x to a new integral with respect to u. So now what happens is the 1 plus x squared becomes u. And I'll have the square root of u. But I still need to account for the 3x here and the dx there. I have to replace those. So here's how we do it. If u equals 1 plus x squared, then the derivative of u with respect to x is equal to 2x. Right? That's just using the power rule for a derivative. Are there any questions up to this step here where I put the check mark? Okay, thank you, Tina. All right, well, all right, I need to find an expression for 3x dx, du dx equals 2x. But what I can do is I can multiply both sides of this equation by dx. Du dx is a derivative, but a derivative is also, hold on. Derivative is slope, right? A derivative is a slope. And a slope has a rise and a run. The rise is the du, the run is the dx, but that's a fraction, right? So I can multiply both sides of this equation, du dx equals 2x. I can multiply both sides by dx. And then on the left side, the dx's simplify. And so what we have then is du equals 2x dx. Du equals 2x dx. And please let me know if you have any questions so far. We're hoping that this is going to work. We're hoping this strategy is going to work so that we can get the antiderivative of this integral. And by the way, the integral I set equal to I. I just always do that whenever I have an integral. I set it equal to I. You know, and you're going to see that's valuable later on. Okay, so right now I have du equals 2x dx. I have 2x dx equals du. But in my integral, I have 3x dx. I don't have 2x dx. So what can we do here to help us? Well, what would I multiply? Let me just clear this for a moment. What would I multiply? Hold on, let me just. Okay, so 3x dx is what I want. what can I multiply 2x dx by so that I have 3x dx? What fraction can I multiply the right-hand side by? That's right, Kahin, Tina, and Michael, 3/2. So I'll multiply by 3/2 on the right side, but then of course I have to multiply by 3/2 on the left side. And when you do that, and I guess I just put the step down here again, when you do that, you're going to get 3/2 du equals 3 dx. Make this a little smaller. Okay? And so now I can replace 3x dx with 3/2 du. And so the integral, the new integral, is going to be square root of u. Again, that's because 1 plus x squared is equal to u, so I have square root of u times 3/2 du. So this integral is equal to that integral. The first integral equals the second integral. Are there any questions on that? Are there any questions? Please let me know. Okay, well now we can, we can find the antiderivative of this new integral. It isn't really a new integral. It's an integral with respect to u. It's this integral here, the integral of square root of 3/2 root u du, is the same as the integral of 3x times the square root of 1 plus x squared dx. They're the same integral. All right. So let me get the antiderivative here of this integral with respect to u. Of course, the 3/2 a constant, and if you remember, you can factor out constants in front of the integral. That's okay to do. And so you'll have 3/2 times the integral of u to the half du. And then the antiderivative of u to the half is 2/3 times u to the 3/2. Maybe I'll show a little step on that here. Hold on. So when you have a power here, so what we're doing is we're doing the opposite of the power rule for differentiation. Right? When you differentiate a variable to some power, the power goes down by 1. So for the antiderivative, the power has to go up by 1. Plus the c, of course. I'll call it c1. So the antiderivative of u to the half du is u to the 1/2 plus 1 over 1/2 plus 1. Well, 1/2 plus 1, 1/2 plus 1, and this is going to all be in the recording. These circles and marks I'm making should be in the recording. 1/2 plus 1 is equal to 3/2, right? But that's in the denominator of the 3/2. So then if you bring it to the numerator, you get that 2/3. And hence, this is your antiderivative. It's an indefinite integral. There are no limits on the bottom or the top, so you have a constant of integration as well. Are we okay? Are we okay up to this step here that I'm circling? Are there any questions on that? Okay, excellent, excellent. Okay, thank you, Snega. Thank you, Eva. Thank you, Rodrigo. All right. Well, now remember, our original integral was with respect to x. So our antiderivative needs to be in terms of x. So what we need to do is then substitute in for u what u was. U was equal to 1 plus x squared. And so the integral, the answer, the antiderivative is 1 plus x squared to the 3/2 plus a constant. A good question, Tina. 1 plus x squared raised to the 3/2 power really can't be simplified. I mean, you could write it as you could write it as 1 plus x squared to the 3rd with a square root. You could, which is actually very pretty, writing it in that form. But you can't simplify it. You can't really do anything with it. Okay, all right. Good question, Tina. All right, are there any other good questions before we move on? Okay, all right. So then we have the antiderivative of 3x times square root of 1 plus x squared. It will be 1 plus x squared to the 3/2 power plus c. And as you know, when you have an antiderivative, you can always check that the antiderivative is correct by differentiating the antiderivative to see if you get the original integrand back, the original integrand function. And if you differentiate that antiderivative, okay, the derivative of 1 plus x squared to the 3/2 power is 3/2 times 1 plus x squared to the 1/2 power, because a half, right, is 3/2 minus 1. And then I'm multiplying by 2x. Why am I doing that? What special rule am I using to differentiate here? Chain rule. Very good, Rodrigo. That's right, Tina. We use the chain rule. And we do have the derivative of a sum, right? And the derivative of the 1 plus x squared to the 3/2 is as you see here. And the derivative of a constant is 0. And we get back, actually, the integrand. So this worked. This worked. All right, are there any questions at all? Okay, that's good. Tina's comfortable. All right. Candace, and I hope you don't mind if I share comments. Candace suggested she might have some reviewing to do, and I understand that. I think a lot of students when they take Calculus 2, since it's a continuation of Calculus 1, you're jumping right in to doing antiderivatives, and of course, there's a saying: when you take a course, when you take a math course, you relearn the course you had before, and so you're going to be relearning your Calculus 1 skills. All right, thank you for that, sharing that input. Thank you, Candace, appreciate it. How many of you feel you might have a little reviewing to do? You might need to review a little bit. Okay, wow, okay, okay, a lot of input here. Okay, thank you, everybody. All right, well, let's go to our next example here. Let's go to our next example. All right, and I'll give you a moment to copy that down. Okay, sorry, I had my volume off here. Sorry. So Serafiel asked a question about the breaks. So what I try to do is I try to give you as much time as I can for you to work on your homework, your classwork, and I want to give you some time to work a little bit on the 5.5 exercises that are due on Thursday. So I hope the last maybe half hour, 20 minutes of class, you'll have some time to get started on those. And so that kind of provides a natural break. Good question, Serafiel. Esther asked also about the last problem. Is that the only way to do it? As far as I know, it is. Now, sometimes you have problems where you can solve them in different ways. Maybe there's several methods, but the way I look at it is, look, if I found a way to solve it, I'm happy, All right, good question. So let's look at this problem here. The integral of x to the 15th power times sine of x to the 16th power. All right, we have to think about what we're going to let u equal. Okay, this is the antiderivative of this It's not one of the simple ones that you learned in Calculus 1. What substitution's going to maybe make sense here?
Is it
So
x
first,
to the 16?
go ahead, Noah.
Is it x to the 16, Professor?
That's right. X to the 16th would make sense. And Rodrigo and Tina agree. Because the hard part of the problem is this sign of x to the 16th power. So we'll let u equal x to the 16th. All right, so let's move to the solution then. So first what I do is I set my integral equal to I. I always do that, and you'll see there's reasons for that. We're going to let u equal x to the 16th. And so the sign of x to the 16th is going to become the sign of u. I'm converting this integral to an integral with respect to x to an integral with respect to u. So, okay, that's fine. We'll let u equal x to the 16th power. But now what we have to worry about is the x to the 15th and dx. That has to get replaced also. Well, of course, we'll do what we did last time. U is x to the 16th power. So let's differentiate u with respect to x. Then du dx is going to be 16 times x to the 15th power. That's using the power rule. Okay, are there any questions up to this step here? Okay, Noah? Yep, question? Tina's good. Okay, all right. So now what we need to do is, well, what should we multiply both sides of this equation by?
1 over 16.
Well, we will be doing 1 over 16, but first, that's a good comment.
dx.
Dx. That's right. That's right. Thank you, Cameron. And I'm assuming I'm when I hope I'm calling the right names when people verbally answer. Candy's right also. Multiplying by dx both sides. And then, of course, what happens is you'll get some simplification here on the left side. And so du is 16 times x to the 15th dx. But as one of you rightly noted, we want x to the 15th times dx. So now what we're going to do is we're going to multiply both sides of this equation by 1/16 to remove the 16 factor on the right side. And by doing that, we'll get that x to the 15th dx equals 1/16 du. And so now we can completely convert the integral to an integral with respect to u. Okay, Snega, question?
It might be a dumb question, but I'm just gonna ask, Professor. So for when you said let u equals to x to the 16, right? Why did you subtract for the exponent instead of like adding and then divide it by?
Are you referring, Snega, to, and you know, so I encourage questions. There's no dumb question. Are you referring to like this step here?
Like you know where you said let u equals to x to the 16,
Yes.
and after that we did du over dx, and instead of subtracting the
So du over dx, that's notation for derivative. That's Leibniz notation. We're taking the derivative of u with respect to x.
okay, okay,
And of course, then that would then be 16 times x to the 15th. But when we take the derivative of a function, you know, we recognize that. I mean, derivative is equivalent to what? What is a derivative? You learn in Calculus 1, a derivative is equivalent to what? It begins with an s. A derivative is equivalent to finding that's right, Sergio, a slope. A slope has a rise and a run. So du dx is like rise over run. Does that help you, Snega, feel a little more comfortable?
yes, professor.
Excellent, excellent.
Professor.
Yes, not now.
So when we made the transition, I understand where we got the sine u, but I'm kind of having a difficulty on how we moved the 1 over 16 from the left to the right side for the then part.
Well, okay, I see your point. I see your point. This integral here, watch this. I'm going to write it. Would you agree that I could write that integral as the sine of x to the 16th times x to the 15th dx?
Yes.
Yes, so the first integral equals the second integral. Okay, well, x to the 15th dx, we replace it with 1/16 du.
Oh, I see. Okay. Okay, that makes more sense. Thank you.
Okay, great, great. You're welcome. You're welcome. Are there any other good questions? Those are very good questions. Okay, well then let's proceed on here. So now the integral, instead of with respect to x, it's with respect to u. And I can factor the 1/16 out in front of the integral. And the antiderivative of sine is minus cosine. How many remember that from their Calc 1 days? Okay. Arian did. Wonderful. Stega. Yeah, so, you know, thank goodness you learned that, right? Okay. Shial and Michael and Shalom know what I'm talking about. Esther, yeah. Everything you learned in Calculus 1 is going to be used here. Yes, Eric, that's right. And so now my integral is equal to negative 1/16 cosine u plus the constant of integration. And WebAssign is going to want the constant of integration. Unless they have it put there, you're going to have to type it in. Okay, or WebAssign won't accept the answer because this is an indefinite integral. Okay, are there any questions up to here before we move to the next page? If I were to type in WebAssign, okay, thank you, Tina. If I were to type in WebAssign negative 1/16 cosine plus c, would WebAssign accept that answer? Would that answer be correct? What do you think? Serfiel
No.
thinks yes, Justice thinks no. I always like it when smart people, there's difference of opinion. Could we give a reason why maybe it would not work? That's right, Shalom. You need to plug your x back in. In other words, the original integral is with respect to x. So your answer has to be with respect to x. So we're going to plug that. That's fine. And I do not worry about chatting out an incorrect answer. It's okay. You're learning, and by participating and sharing, you'll retain information better. I encourage participation. So, okay, well, all right, we're going to do that. We will replace the u with the x to the 16th power, and therefore, we have our antiderivative. Okay, give you a moment to copy that down. All right, are there any questions on this one? Okay. Well, we did 2 indefinite integral problems. Let's do a problem where we have a definite integral. Okay, let's do one where we have a definite integral. That'll be our next example. Okay, so take a moment to copy that example down. Okay, so, well, always, I don't know the antiderivative offhand of that, and better make a substitution. But the question is, what should we let u equal?
1 plus 3x.
Sounds good. Snega, that's you who said that?
Yes, Professor.
Very good. Most definitely, 1 plus 3x. Okay, so this problem's going to work like the last two. The only extra thing we have to concern ourselves with are these limits of integration. So let's go ahead and move to the solution here. So I'm going to let u equal 1 plus 3x. Okay, so the 1 plus 3x becomes u. Now what's left is the x dx. So you could treat this like this. I mean, I think this might be helpful. Okay, so that's a times symbol there. So the 1 plus 3x is the, well, I want to say this the right way. Let me say this the way I want to say it. This here is going to become 1 over the square root of u. What's left is we have to find out about the x dx. We need to replace that, and also we need to replace the limits too. So first what we're going to do is, just like the last two problems, so u equals 1 plus 3x, we're going to differentiate u with respect to x. So du will equal, du dx will equal 3, because the derivative of 1 plus 3x with respect to x is 3. And then du will equal 3 dx. And so dx will equal 1/3 du. And so now dx is 1/3 du. And I'm going to talk about this step up to the right. I'm getting there. So far, we good? All right. All right, wonderful, wonderful. Well, so the only thing left is that I have to worry about, the only thing I've not replaced in my original integral with u terms is the x. I don't know why it did that. Don't worry about that. It's the x. So the x, well, I have to solve x in terms of u. So if u minus 1, and don't worry, sometimes I get kind of a big line that shows on the screen. Ignore that big line segment. If u equals 1 plus 3x, what's x? Well, u minus 1 would be 3x, so x would be u minus 1 over 3. And that's why I do this piece to the right. Sometimes you have to do that. You know, sometimes you have to do it. Okay. I kind of, sometimes I compare integration to like wrestling, you know. like the guy or the woman, you know, is in the match and maybe they're losing, and so what do? They have their buddies come to help them. You know, they do what they need to do to win, and that's how I look at this. We're doing what we need to do to transform this integral into an easier integral. The integral with respect to x was too difficult. Well, what's the integral with respect to u going to look like? Here it is. So let me take that off there. So I have everything replaced here in the in my integral. It's still the same integral, only it's an integral with. It's still the same integral, only it's an integral with respect to u. However, we have to worry about the limits now. This is a definite integral. I can't just drop the limits. I have a definite integral. I have to put in my limits. The limits 0 and 5 were limits with respect to x. For the new integral that's with respect to u, I need to put in u limits. Well, u was equal to 1 plus 3x. So when x is 5, we replace the 5 with the 16 because 1 plus 3 times 5 is 16. Similarly, for the x limit of 0, the bottom limit, we're going to replace 0 with 1 because 1 plus 3 times 0 is 1. So are there any questions up to this step here before we move forward? So it should, yeah, Marcella? There was a question?
Where do you get the 16? Like, can you explain that part again?
Oh, okay. So, Dan, would you agree that I have to put in, since my new integral is with respect to u, I need to have u limits here in the integral?
Yes.
Okay. So, well, what was u? U was equal to 1 plus 3 times x. So when x is 5, u would be 16.
Okay.
Very good question. And when x is 0, u would be equal to 1 because 1 plus 3 times 0 is 1.
Okay, thank you.
You're welcome. All right. Are there any other good questions? All right. Well, we're gonna move on then. So this integral, I'm gonna rewrite this integral here is, I want to find the antiderivative, so I got to simplify things. Well, I notice I have a third here, and I have a 3 here in that top fraction, so I can factor a third and a third out, and that's going to leave me with this integral. 1/3 times 1/3 times the integral from 1 to 16 of u minus 1 over the square root of u du. Are we okay on that step? Okay, excellent Tina, excellent Jonathan. Excellent Arian. Oh, okay, Cameron's a little uncomfortable. Cameron, where are you uncomfortable?
Could you go over like the 1/3 times 1/3 one more time?
Sure. Yeah, let me give myself a little space here. So this u minus 1 over 3, that's the same as 1/3 times u minus 1, right? So that's how I get the the 1/3 times 1/3.
Okay, thank you.
You're welcome. Are there any other good questions? Okay. Now, we need to do something with this u minus 1 over the square root of u. We can't integrate that as it sits, but we can rewrite that fraction. Anytime I have a fraction, I think about rewriting the fraction. It's sort of a natural thing for a mathematician to do. So let's go to the next page here. You remember we had u minus 1 over the square root of u. I'll write that as u over square root of u minus 1 over square root of u. I mean, certainly I can take a fraction and, I mean, if you had u over the square root of u minus square root of u, you agree that that whole thing would be equal to u minus 1 over the square root of u, right? Because you're just combining the fractions. Well, then u minus 1 over the square root of u can be written as u over root u minus 1 over root u. Okay, so it's sort of like I'm doing what I need to do to solve the problem. And we're going to get an exact analytic answer. And that's, by the way, what WebAssign's going to want. For their answers, they want exact answers in simplified radical form. Okay, so that's what you have to strive to get, not decimals. Not decimals. Okay, so u over square root of u is u to the half, because u over the square root of u is u over u to the half. And when you have u to the first over u to the half, okay, let me just trying to justify, I'm taking this. You do what with the exponents? You subtract the exponents. So that gets you u to the 1 minus a half power, hence u to the half. 1 over the square root of u is u to the negative half, because one over the square root of u is like 1 divided by u to the half, and we bring a positive exponent up to the numerator, we get u to the negative half. How many remember doing that in pre-calculus? That sort of thing. Sure, Candace knows that, and maybe algebra 2. How many remember that maybe from algebra 2 in high school? Sure, Michael's right, knows, and hey, here you're using it again. Okay, so now, thank you, Shalom. Now we have an expression now that we can find the antiderivative of using the opposite of the power rule. The antiderivative of u to the half is 2/3 times u to the 3/2, and the antiderivative of u to the negative half is 2 times u to the half. Okay. Let me know if there are any questions up to here. And I know that some of you need to review your power rule, but are there any questions? All right, well now what we have to do, we have to compute this definite integral. And you know, we're computing the area under the function. I mean, the area that we're computing is the area between 0 to 5 under the function x over the square root of 1 plus 3x. Now, I want to make a comment here. At this stage, we have the antiderivatives. We have our antiderivative, and we can just we have our antiderivative with respect to u, and we can plug in our u limits, 16 and 1. Sometimes what students want to do is when they get their antiderivative with respect to u, they want to substitute the u back in and then change the limits to, well, what they want to do sometimes is they want to put in u is equal to 1 plus 3x. So at this stage right here, sometimes I've seen students replace the u with 1 plus 3x and then change the limits to from 1 to 16, change it to 0 to 5, the old x limits. But why do that? You don't need to do that. You have your new u limits. You have your antiderivative with respect to u. Just plug in your u limits. I've even seen that, you know, that where they go backwards. I've seen that, you know, even maybe in a occasional tutorial, you know. But why do that? You have your new u limits. Just work with those. Make your life easy. So you put in the 16 in the expression first, minus, then you put in 1 in the antiderivative expression. So 16 goes in the antiderivative expression first, minus, and then the antiderivative expression with 1. And then this just is evaluation. This is just computation. And you're going to get ultimately 1/9 times 108 over 3. You could, like in your calculator, you know, like for this part here, well, for this part here, you could, you know, use MathFrac on your calculator and combine all those fractions, and you'll get 108 over 3. So are there any questions in general?
I have a question.
Yes, hold on, let me just, yes, not no.
Okay, so for the third step, did you put, so do you divide the well, I think I see what I was just gonna ask you where you got the 16 and 1, but that's from the integral
Well,
of the
right,
yeah.
Good question. Those are our limits.
Yeah, okay.
Okay, are there any other good questions? Okay. Then I'll move to the next page. I don't want to go too fast. Does anyone need a little more time in copying? Okay, Alan, all right. So, okay, and you know, I'm just being structured. Well, So the final answer then, and I'll move to the next page, you would want to simplify this a little more. We went to all this trouble, we might as well simplify our answer. Good question, Shalom. So the final answer, Alan, you're good now? Okay, great, you're welcome. So 9th times 108 over 3 is 4. And so this is the answer. 4 is the area. It's and this function x over the square root of 1 plus 3x is going to be positive from 0 to 5. So if we were to draw the function x over the square root of 1 plus 3x from 0 to 5, and you know, what would the area be underneath that function, bounded, you know, the area bounded above by the function and below by the x-axis from 0 to 5, that area would equal 4. Okay. And we're going to do, we'll do a few more, at least one more definite integral. For your section 5.5 exercises that are due Thursday, those are going to be indefinite integral problems. But I thought it would be good that you saw a, you know, one definite integral problem. I'm going to stop the recording.